Hello, welcome to the podcast that's going to talk about reflections in our geometry units. Um, Go over some progress that I've made in the last 2 years, actually a year and a half, when I started doing the transformations in core geometry, kind of what I've built so far. By no means, which is this, kind of some concepts in the order that I would do them and just highlight some things. But I'll talk about what each app is and what each assignment that I made or used covers and why I like them. Um, it's been a year and a half, I guess, to do transformations, and I find a ton of success in there. By no means what I have is perfect, but it's definitely, I think, progress. It's working in the right direction. So hopefully, after these units, you can kind of see what I've discovered. So the biggest thing with reflections is really the geometry is the perpendicular bisector theorem, which oddly enough I don't have written down here. I do have it. Well, right here actually, number 3. This is our perpendicular bisector theorem, so to speak. But the main thing, the geometry behind reflections is just that. And I'll explain that to you when we go over this. So again, back to this picture here. This was in our math meeting that we had. This is my talk about our transformation. So hopefully we can go from this number pattern and graphing via multiple representation and being fluent, I think, for students is good. Then I think we should transform in geometry and our algebraic equations also in the same conversation, so that when we talk about functions, we can do parent functions and all these terms and whatnot can fall out. But when we transform our parent functions, we're creating expressions and equations. The algebra side is going to connect back to the geometry. That after these units, I think that our students are going to have a really good understanding of orientation of our transformations, and then connecting to table values. The algebra side of it, kids are going to have a really good understanding of our different kinds of equations. So with reflections, here again is the Dropbox information. In the Dropbox, just like in the other podcast, I talked about how if you go to Dropbox, here's our username, password, and you sign into it, you're going to find let me just get this here. So you'll find in our Dropbox, in the new GeoGebra apps for number patterns and transformations folder, if we click that, we have our different units here. So in our unit reflections unit, these are all the resources that I've used and kind of compiled as a unit, and I'm going to go over each one of these, so hopefully you can see what I'm talking about. Alright, so anyways, that's in our Dropbox. Alright, so number one, first thing that I would do with reflections, and this is what I kind of thought about, was what is a reflection? So I want students to understand the orientation after an object or an image point, whatever, gets reflected. Where does it go, and what's the orientation look like? And then what's the geometry behind reflections? So I wanted to investigate the properties. To help do that, we have I made this mountain reflection app, okay, which is this GeoGebra app here, Mountain Reflection. So what it is right now is just a picture where we can see symmetry, right? We have the lake, it's reflecting the mountain in the sky. So we can do some fun stuff with this. I don't know whether we should do this activity first or the Mira activity, which is number 2 on the list here. Reflections with Mira activity. Investigate properties of reflections. So I don't know, do we want them to kind of explore with a computer program first? I'll do the app and show you what I talk about, and then I'll go over this and maybe we can discuss which one we think should go first. Either way, let's talk about the mountain reflection app. What I would do is, first of all, talk about where, they can see a reflection, they know what reflections are, ask them where the line of reflection is, and they're going to tell you it's the shoreline here. So we can actually grab our line tool. Now, I want right now when I make this, it's going to be a boring, thin, black line. You can change before you make any object, points, lines, anything. You can change their color before you make it, and like their thickness. So I want mine to stand out here. I'm going to make my line of reflection maybe red. So I'm going to click red. When I click this option drop box here, it changes my line style. So maybe I want my line of reflection to be dotted or solid. It doesn't matter. But this is our thickness meter down here. So I'm going to make it pretty thick. And you can see the line up here changing. So maybe like that. So now what I'm going to do is just put my 2 points down, and there's my line of reflection. Okay, so now we can see, all right, there's, that looks like that's our, line of symmetry. Now what we can do is do some exploring. I'm going to grab my new point tool, and I'm going to put a point on, this mountain silhouette or line here. So maybe like right here. Now notice that point is blue and boring. The other way to change an object is once you've made it, just click on it, and now we can go back to the options. Maybe I want this point to be this green color, and I want it to stand out. So I'm going to make it pretty big. So now F is just a point, right? Anywhere. But I'm going to put it on the mountain. Now we could do some things here, depending on the discussion that you want to have. What I would do is use the reflection tool. So if we click, this is our transformation toolbox in GeoGebra, so we can reflect an object about a point, which is interesting, and then reflect an object about a circle, which that's a whole new geometry problem in itself. You can rotate and you can translate and we can dilate. Okay, so reflect object about line. So now what we need to do is tell GeoGebra what we want to reflect. On mine right now, I have my point F is highlighted. You can kind of see it by the dot, but also in my algebra window, it's showing me that it's highlighted. So right now, I'm telling GeoGebra, since that's selected, I want to reflect this point because it's the only thing highlighted here. So now I'm going to just click on the line of reflection, and it went and made the reflection point. Okay, so now as you move F around, its reflection point is going to stay in relationship to our line, right? So, I'm just moving point F along my mountain skyline here, and my reflection point's off a little bit, like right there, for instance. You can see that it's off. So my line is kind of off. I would just move my line of reflection, and now that looks good. Okay, we're looking all right there, and then over here, we're pretty good. So I'd say our line of reflection is good. Now, what we can do too, which is kind of interesting to see, as we move this point F around, I want to trace where it goes. So I'm going to right click my point F, and I'm going to go to trace on. And then I'm also going to do the same thing with my reflection point. So I'm going to right click this point and turn my trace on, so that now when I move F, it's actually going to map out. Oh, it's not. It's actually mapping out, but the picture, the way GeoGebra works, the picture is the front layer. So if I grab my move tool, and I right click and go to object properties, right click my picture, go to object properties, one of these options I can do is background image. So I'm going to change that to a background image. And that didn't work. Maybe if we go to color, we change the opacity of the picture. So we can actually change the opacity. So now when we move F, you can see the points, right? So now, as we're messing around, students can see the reflection. They know mountain reflection. That makes sense to them. Right now, we just made the reflection point by the line of reflection. So now we can see that, okay, I buy into that this point is the reflection. If I right-click my image, I can click show object, and now there's no picture. So now we're not stuck to the mountain was there as a guide for us to see the reflection happen. But now as we move F around and its reflection point stays there, we can make some cool shapes that are symmetrical, right? If you're done, you want to do something else. Like, okay, this is too messy, I want to clear it. If you go up to View and go down to Refresh Views, Control F, refresh views. Click that and your trace will go away. The trace is still on, so as we move F, F prime will move too. So as I'm moving my line of reflection around, you can see that the reflection point moves as well. And I kind of pause there because as I'm moving this, it's kind of neat that that makes an arc, which is our reflection property stuff. But now what I want to do is, okay, so we've explored reflections, right? We have the trace on, we can use that, we can make whatever we want, you know, nice symmetry concept. Okay, we can change, refresh view, we can change our line of reflection, maybe make it vertical. That's kind of neat, right? This is a reflection, but as I rotate my line, we got a circle made. But maybe I have a vertical line of reflection, so if I refresh again, I can try to make a butterfly or something, you know, something that has nice symmetry to it, right? So, something like that, right? So, we can mess around with symmetry with GeoGebra with this app. The other thing that I would do next is talk about properties of reflections. So, I'm going to turn my trace off. So, trace on, I'm just going to click trace on again, which will turn it off. I'm going to refresh my view to get rid of my butterfly that I have. So now when I move my point F around, it's still moving. Our reflection point is. So let's investigate some properties. The two things about reflections, the two properties that I want to talk about, and I'm just going to pull up a worksheet here that I'll talk about here in a sec, finding lines of reflection, but I put the properties on this worksheet for my students. So these are the two properties of reflections that happen that I want to get my students to understand. The first one is the pre-image and image points are equidistant from the line of reflection. Another way of saying this, if you connect corresponding pre-image and image points with a segment, the line of reflection will bisect the segment. So that's our first property. The second one is the segment connecting corresponding pre-image and image points is perpendicular to the line of reflection. This means that the segment and line of reflection meet at a 90-degree angle. Okay, so I want my kids to understand those two properties. So in the exploration, if you're leading a group discussion, I would have all my kids have a laptop and follow along with me. But I'm going to connect the pre-image and image points with segments, and those are the terminologies that I use as well. When we talk transformations, the first object point or whatever is a pre-image. After you transform, it becomes an image. Okay, so now that I connected, we can see the bisecting here by the line of reflection, right? But we don't know it yet, so we can explore those properties. I'm going to grab my new point tool. If I click right on the intersection, notice when you do that, the box comes up, tells you what you're highlighting. So as long as both those are up, I know I have the intersection. So when I click a point there, I have my dark point that I know is my intersection. So now what we can do is we can measure equidistant if we want to by grabbing our measurement tool. So in our measurement toolbox, I'm going to go distance or length tool, and I'm just going to click on my 2 points, and it's going to tell me the distance between those two. And then I'm going to do the same thing here. All right, so now we can see, oh, bisect, equidistant. So pre-image, image points are equidistant always. Now the second property says that the segment connecting the pre-image and image points meets at a 90-degree angle to our line of reflection. It's perpendicular to. So I'm going to make an angle. I'll just use these points that are my line here. So as I change my line, I'm going to measure this angle right here. Okay, so back to my measurement toolbox, grab the angle tool. When you select points, you have to go in a clockwise direction. So if I'm going to show like this angle right here is 90 degrees, I'm going to go D, then G, then F prime. So in a clockwise direction, I have to select my points. Vertex is always the second point. But now we have, oh, look at that, 90 degrees, right? So no matter where I move this, now, because I defined my angle with D, depending on what side of the angle or point D I'm on, it makes the angle. But you can still see 90 degrees, and we can argue, this is 270. We can make some good reasoning that that's got to be 90. But yeah, there's our properties of reflection. So we did it with the mountain scene. they kind of buy into reflections. And then when you hide the picture, now we just have the geometry showing of a pre-image and an image point after a reflection, and we can do a quick little investigation of the two main properties of reflections. Alright, so now the next thing that I would do with reflections, go to our list. So what is a reflection? Orientation and properties. Also, this reflection properties with bugs app is going to be good. The reflections with Mira activity is this PDF here, and you're using the Mira to draw. So this, you want to draw the image of this boy so that he's on the swing. As you move down, this one is, use the Mira to make your the earring go onto the ear. I have my kids draw off their mirror. They just trace the mirror line, draw their line of reflection, so we can look at those properties as well. Okay, so we can get more buy-in on bisecting and perpendicular. Okay, so through this activity, it just kind of tells us what to do. So like on this worksheet, you're going to place the mirror between P and A, move the mirror so that P maps onto A. And I had them draw the line of reflection, and then I also had them label it, A, because it's point A. And then if they're going to reflect P onto C, they're going to draw that line of reflection and label that line C, because it's point C we're mapping onto. Okay? Same deal here, just talks about what you should do with the mirrors. So good activity where kids are drawing reflections, okay, hands-on stuff versus just computer programming. Okay, so that's that worksheet. Explain that a point on the line of reflection is equidistant. So what I mean by that is, let's say that I want to create a quick little app here that just reflects a point over a line. So maybe I'll just make a line of reflection, put a point out here somewhere that I'm going to reflect, and I'm going to grab my reflect tool. Since nothing's highlighted when I have my reflect tool, I have to tell GeoGebra I'm going to reflect point C over this line here. So now that's the order that we have to use the tool. Okay, so really what the theorem says is, and I'm going to put another point and use this. Maybe I want this one to stand out. Maybe make it red. So really what my theorem is that this point D, any point on this line, it's going to be equidistant to our pre-image and image points. So what I mean is, if we connect with the segment, those segments are going to be the same length, right? Now, this is where isosceles triangles come in, because that segment that connects pre-image and image points is now the base, and the line of reflection becomes our line of symmetry. It bisects the base perpendicularly, goes to the vertex point of our isosceles triangle, and we're building some good geometry concepts here by seeing this. So this is really what the perpendicular bisector theorem says. Any point on the perpendicular bisector of a segment is equidistant to the endpoints. We can see that here, and we can see the isosceles triangle with reflections. Okay, and maybe we want to show the perpendicular too, and the bisect. So we need this intersection point. So I'm going to grab my new point tool, grab that intersection, measure the distances here, so it's bisected, and then measure the angle clockwise. Maybe I want to do this one, so I'm going to go C, E, A, and we can see the perpendicular bisector theorem here, which is the equidistant. That's what builds the the isosceles triangle concepts in our geometry, just based off of reflection. So really, when we reflect a point over a line, we always create an isosceles triangle. That's the geometry behind our constructions that we make and everything. Okay, so that's what I mean here by number 3. This app here does all that and everything here, all our properties and this perpendicular bisector theorem. Okay, so let me explain the bugs app. What I like about my transformation apps is I have these buttons here. So if you just follow along, and I'll explain and show what each one does, you can do different kinds of discussions. So you can come back to it and hit this app with a different angle on reflections too. So when we reflect an image, so computer animation, whatnot, we have an image here. Oops, I don't want to actually move bugs. When we talk about reflection, really we only need to look at some key points. So if you click this first box here, it puts up what I call key points. They're all different colors here. Okay, so what we're going to talk about is let's reflect this image of bugs over this line here. This is our line of reflection. Okay, so to do that, let's reflect these key points first, right? So after we, do our properties, we can do a couple things. We can use GeoGebra and we can construct the reflection points using our properties. This green point, when it gets reflected over this line, it's got to be the same distance from the line as its pre-image, and the segment, the path that it follows, must be perpendicular to our line of reflection. So, to use that concept, we could either just click on the reflection points if we want to do that. Actually, yeah, we do want to do that. So we'll talk about, okay, here are the reflection points. Let's look at those properties. So here's our segments that connect the pre-image and image points. And then measurements to show reflection properties. So if we actually do that, here's our bisecting and 90 degrees relationship too. So each segment's getting bisected and they're perpendicular. So then I can actually click on the bug's picture and I want to reflect it. So it's already highlighted. I'm going to grab the reflection tool. Now I just have to tell it to reflect over this line so we can see the actual image get reflected. Hold on, I'm going to pause this podcast here. I got a crying baby. Be right back. Okay, I'm back. Hopefully he's not crying anymore. Okay, so back to the app here. The last thing that I wanted to show my students is we have all these segments here, right? Each of these different colored segments are really a base of an isosceles triangle. And the vertex point of our isosceles triangle is that any point that's on this line of reflection. So I wanted to show that as well. So when you click this last box, you can see point C come up and it creates those equidistances. So we have the perpendicular bisector theorem that's explaining these isosceles triangles. And so now we can see that all the bases are perpendicularly bisected and go through the vertex point. So we have all these isosceles congruency concepts here, right? Reflection, we could fold on this line, and points map onto other points. And that's the vocab we need to use as well, mapping onto. That's how we can talk about transformations forcing figures to be congruent. Okay, so that's the Bugs app. That's a big one, I think, for reflections. The next thing is, so up to that point, we've just been exploring reflections, right? We've looked at mountain reflections, we've used the mirrors, we've drawn actual reflections, we've talked about the line of reflection, the perpendicular bisector theorem, and then we've explored the properties again with Bugs Bunny showing multiple isosceles triangles getting formed. Okay, so now let's do some construction stuff and construct some reflections. So the fifth thing that I would do is find the line of reflection by construction, show how to construct a perpendicular line and a perpendicular bisector of a segment. Now, I would do these by hand. So, let me see here. I'm going to show you with the tools here. So, by hand, I would have the kids have a compass. So I'm going to grab my compass here with the Smart. So I have a little tool here. And then a straight edge, right, a ruler or something. So that's just going to be my segment tool. So perpendicular construction, all we have to do is use the endpoints as centers of circles, right, with our compass. And if we're just making a perpendicular line, then it doesn't really matter what our radiuses are. So I'm going to make this circle here, right? And as long as I make this endpoint the center of a circle, and I have radii that intersect. Oops, like these ones don't. Hopefully these will. There. Then we got our perpendicular line. Now to prove it geometrically, it's all about the perpendicular bisector theorem. So what I mean by that is when we get our kids to understand why this construction works, it's because with the circles and radii, like this point right here, let me grab my pen, is the center of the circle, and this is the radius of the circle, and this is the radius of the circle, right? These are congruent. So then this point must be on the perpendicular bisector of this segment right here, right? Just like we've been talking about. And also, same deal here. Here's our center, right? And here's a radius. Here's a radius. These are congruent to each other. Therefore, this point must be on the perpendicular bisector of this segment as well. So therefore, that's what the construction is doing. Notice we have a nice kite right here, right? When we put two isosceles triangles together with the same base, we create a kite. Okay, so that's the perpendicular construction. If you want to do the perpendicular bisector, then just keep the same radius. Okay, so once kids can understand how to do the constructions of the perpendicular line and perpendicular bisector, then we can actually start constructing reflections. This, though, is how we can find the line of reflection. So let me show you. Let's find the line of reflection here. So find LOR, line of reflection. So what I'm going to do is just put 2 points up here, right? So one of these is a pre-image point, one of these is an image point, and it's been reflected. So there's got to be some line that it's reflected over, right, to map this point onto this point. So let's just use those construction concepts here. If I make the segment that connects these 2 points, that's like the base of an isosceles triangle, so I need to find the vertex, right? So the vertex is going to be on that perpendicular bisector, which is our line of reflection. So let's construct the perpendicular bisector then. So all we have to do is I'm going to use my circle with center through point, and they need to do this by hand as well. But with GeoGebra, I'm going to click on this point as my center, this point's going to be on my circle, this point is, and then I'm going to do another circle. I'm going to click this point as my center, and this point's on my circle. So they have the same radius, right? Which then creates, when we connect the 2 intersection points, creates our perpendicular bisector, which in this context is our line of reflection. So now we have our line of reflection here no matter where we move these points, and we can hide our circles if we want to. So right click in our segment. So now we know that we have a line of reflection no matter where our points are. Right? All based off of perpendicular bisector construction and looking at the properties of our reflections. Okay, so we've got that. Then I created building concepts. I wanted students to start understanding congruence and the construction. Why does the construction work? What's the geometry behind it? So I created this worksheet or activity that's called Building Concept of Congruence and Construction. I have here the perpendicular bisector theorem. Okay, and then I wrote some stuff. Since we don't have textbooks, I still want students to read math, which my students didn't really read it, but there's some good math thought here. And then what I have is the concept breakdown, talking about our construction that I just went through. So the concept breakdown, I have them following steps where they're going to actually construct the perpendicular line and perpendicular bisector. Then after they follow those steps, use these concepts. So construct the perpendicular bisector of this segment. Explain your thought process. Don't worry for construction and writing overlap. So if they draw all over this, who cares? Okay, construct a perpendicular line that goes through the top half of the segment. So that was interesting. They need to understand midpoint, and then anywhere above would be the top half. So they had to construct a perpendicular line, which means center at B with a smaller radius, center at A with a larger radius, so that those overlapping regions happen up here. Okay, that's what I want them to explain. Go through the right side, so here's the middle. This would be the right side, so same deal, make a perpendicular line. This one was a hard one. I made it without thinking about it, but still, it's good discussion. How do you make a perpendicular line go through an endpoint, right? So basically you're making a right triangle. How do you construct that? Okay, so that's that worksheet here where they go through the concepts. By question, I broke down the concepts of our construction, of our perpendicular lines, and then now I have them make some some perpendicular lines. So that's what I mean by building concepts of congruence and construction activity. Okay, construct a reflection of an image about a line. So now that we've been talking about all this stuff, another assignment that I have is constructing a reflection of an image. Oh, my bad too. I was looking at this worksheet here. Finding lines of reflection. I didn't have this on my list. I should. Oh yeah, I do. Sorry. It's right. I should have said this too. Finding line of reflection by construction. I have an activity that goes with this where now that we've talked about how to find the line of reflection, here are some reflected images right here. There's 4. They need to find the line of reflection for each one of these, which I tell them use 3 pre-image points on each problem. So if this dolphin here is considered a pre-image and it's going to reflect to this one, I'm just going to put 3 key points up here, and then I'm going to find their corresponding image points over here, connect them with a segment, find a perpendicular bisector. And I wanted 3 segments just so they can see each one getting perpendicularly bisected by the line of reflection. Okay, number 5, same deal here, just a picture from GeoGebra. Okay, find the line of reflection. This part here is use the properties to prove or disprove whether these are actually reflections of each other. So they have to think about both properties being satisfied. Are these an actual reflection? So they're going to go through the process of constructing the line of reflection, and they're going to find out that if, like this one here, these aren't a reflection because I slid this turkey up a little bit, so it's actually a glide reflection. But once they find their line of reflection, they're going to see either not perpendicular with one of the segments, and also maybe not bisected. So that's how we can argue whether something's a reflection or not. So I've got a few of those. Okay. So when they actually make the line of reflection, they'll see that the properties aren't being satisfied if it's not a reflection. Okay, so back to the list here. So we've talked about number 6. Construct a reflection of an image about a line. So here's another assignment that I have. Construct the point. So the perpendicular bisector theorem. I hit it a bunch of times because that's the key behind all of our transformations, really. So they need to construct with a compass and a straight edge the reflection point. Okay, which is a good math question. So they need to construct this reflection, and this reflection. So there's only 4 problems on this assignment, but it's a good one. What I did with this assignment too is in GeoGebra, I'm going to clean this, get a new one here. What I did was I actually took screenshots of these problems, of each one of these, 1, 2, 3, 4. So I took a screenshot of them so that I could actually paste them in GeoGebra. So to do that, in our insert text toolbox, we have insert image tool. So if you click that and we click somewhere on the screen, we can put pictures in GeoGebra. And so my problem 1 through 4 here are my screenshots of these problems from our worksheet. So number 1 is this number 1 right here. And what I like about this is now I can put a point on that point. I can put a line overlapping this line, right? And maybe I don't even want these points on here. I'll get rid of that one and this one. So now let's construct that reflection point. So they need to know that, after we reflect this, it's going to end up, they can visually see, I hope, that, perpendicular and equidistant, it's going to be somewhere like right here. So the perpendicular bisector theorem, again, why it's on this worksheet, is how we construct the reflection point. So this is our line of reflection. It's the perpendicular bisector of the segment that connects this pre-image point and its image, but we don't have the image point. So that's an interesting concept. So what we can do is, if we put a point on our line of reflection, that's going to be equidistant. It's going to be the distance that this point is from our pre-image has to be the same, right? Which is circles. We got congruent segments, we need circles. So I'm going to create a circle with this point on my perpendicular bisector, the line of reflection, as the center, and then my point I'm reflecting is going to be on the circle. So its reflection point has to be somewhere on this circle here because it's equidistant to this point, perpendicular bisector theorem. So now the next thing is, how do we find where that is? Well, if we do the same thing, if I grab my point tool and I put a point on the line of reflection and I'd make a circle with this point as the center, now, because this overlapping region, the perpendicular bisector theorem is satisfied here by this equidistant here, this radius, and also this one, right? So now I have my reflection. So when the students do this by hand, the next day they can use GeoGebra, or I can do GeoGebra as we correct to show the correct process of how to find the reflection point. So there is number 7 here, construct a reflection. And then the last thing is, and I've been hitting all this, I hit all this throughout the whole unit, but I want to really just focus on isosceles triangles and symmetry. The congruent parts, since we can talk about congruence, right? So we have these isosceles triangles that get made, right, all the time when we reflect, based off our perpendicular bisector theorem. Now we have two congruent triangles in here, right? So we can say that this angle, after not only points are getting reflected, but also angles and segments, if we take this angle here and reflect it, so I'm going to take this and I'm going to reflect it over this line here. Notice it reflects onto this angle here, right? So they can see the orientation of a reflection and mapping corresponding parts as well. So I wanted to go over those with you. And then I have the test on here as well, which I didn't have pulled up. All right. So in my test, I had some vocab here. I really wanted them to use these words a lot, and I'm glad I did this because we use these words a ton throughout rotations, translations, and the rest of our geometry and core that we've developed. So 9 vocab. 2, finding the line of reflection. You must show the two properties of reflections are satisfied. So these are reflections, show the line of reflection, and then also show the properties. So once they draw the line of reflection, I want them to draw me the segments and show that it's bisected and perpendicular. Okay, measure with a ruler and a protractor, or construct with a compass and straight edge the reflected image. So they need to construct. Also, here is a construct the perpendicular bisector of the segment, and they'll see that it's symmetry, right? And then, are these reflections of each other? Why? So 14 question test, but it's really showing some good logic of reflections. So that is the reflection unit. I hope that made sense. Mess around with that, and please feel free to ask me some questions. Thanks, guys.